हाँ मैं और कैसे चल रहा है प्रिपरेशन? सही चल रहा है, चलो ठीक है. So we have started discussion about vibrational rotational spectroscopy, right? And what we have observed that you can get pure rotational spectra, but you will never get pure vibrational spectra. So vibrational spectra will contain rotational line also, and we have derived these things, that wave number corresponding to the transition, that was nu dash, sorry,
सर
yes,
आवाज आने लगी.
किस आवाज आने लगी?
यस सर.
आप बताओ.
सर आ रही है सर.
अब
अब बंद होगी सर.
okay, so you have derived these things, right? And nu naught was your fundamental band. So basically that transition is restricted for vibrational level, that was from 0 to 1, and there was no restriction for rotational transition, but rotational transition is happening from the rotational level corresponding to V0 and rotational level corresponding to V1, right? And we also have seen that rotational constant, in fact, it is not constant when we will changing that vibrational level. I mean, for V0, we have assumed that is B double prime, and for V1, we have assumed that was B dash. And in fact, what we have seen, since that rotational constant is depends upon bond length, so obviously for V0, that bond length will be small. That means that B double dash will be greater than B dash. But there will not be that much change in bond length when you will go from V0 to V1. You know, that there will be not that much significant change when you will go for from V0 to V1. So we can think of that B double dash will be almost say similar to B dash, because there will be slight change in bond length, because they are almost close level. But let me write this transition wavelength, that the transition line or wave number corresponding to the transition for rotation vibrational level, that is from V0 to V equals to 0 to V1, that will provide you fundamental band. And you have rotational term, that was how much? So it was B dash, if I am correct, then J double dash, say, sorry, J dash plus 1. So these things actually for upper level, right? I mean, the rotational level corresponding to V equals to 1. Then you will have B double dash and J double dash, J double dash plus 1. Okay. So that rotational quantum number corresponding to V equals to 0 level. Okay. So now we'll have two cases. One is, we'll have two cases. So let me discuss first case 1, when J dash minus, or let me write it in short notation, that is delta J equals to plus 1. Because we have two selection rule, that is delta J plus minus 1. So we'll discuss one by one. So let me discuss first delta J equals to plus 1. What does it mean? It means delta J, sorry, J dash minus J double dash, it should be equals to plus 1. So now I'll substitute in place of J dash in this equation as J dash equals to 1 plus J double dash. So I'll substitute it here, then you'll get nu dash equals to nu 0 bar, and I have discussed this nu 0 bar, right? That is omega e into 1 minus 4x. And these things will come out. So B dash, these things will be J double dash plus 1. And of course, you'll have another term that will J double dash plus 2. And last term will be B double dash, J double dash plus J double dash plus 1. Okay. So if you solve it, you'll get let me solve. So b dash. So these things, if you break it, j double dash square plus 3j double dash, then we'll have 2 minus b double dash j double dash plus 1. So now we'll take arrange this term. So first we will have constant term. So that will be simply 2b dash. Then let us take j double dash, coefficient of j double dash. So from here you will get coefficient of j double dash, and from here you will get coefficient of j double dash. So if you take j dash double dash coefficient, it will be simply 3b dash minus b double dash j double dash, right? And last term will be j coefficient of j double dash square. So of course we will have this and this, because these things will give you j double dash square, and its coefficient will be b double dash. So it will be simply b dash minus b double dash j double dash square. Okay. Is this part clear to all? Is this part clear to all?
Yes, sir.
Okay. Now, as I told you, since this transition is basically happening from here to here, so let me write. I'll write. If you have written this part, please tell me. So I'll divide this board into two parts, because I have to draw that transition line. Have you written this part? Okay. Can you please mute your mic? So we have many rotational line. By the way, that rotational line will not be equally spaced. Okay, it will be, that spacing will be increasing with increasing that number of quantum number, but you can do this. Okay. Let me extend it more. So this is the rotational level corresponding to v equal to 0, and these are the rotational level corresponding to v equals to 1. And let us denote that j double dash, that is 0, 1, 2, 3. Here j dash 0, 1, 2, 3. Okay, and we have this new dash, that was new 0 bar plus 2b dash, then you have 3b double dash, sorry, 3b dash minus b double dash j double dash plus b dash minus b double dash, right? J dash double dash square. This is your wave number. Okay. Now, as I told you that there will be not that much change in b, because for v goes to 0 and v goes to 1, there will be not that much change in the bond length. So what we can think at this stage, it will be like a b dash almost close to b double dash. And you can think like if b is 5 centimeter inverse, let us take a rough example. So it will be around 4 centimeter inverse. Now, first transition will happen, that will be corresponds to what? So
Sir,
yeah.
ನೀವು symbol less than का निकाला है, less than or equal to या similarity का?
हाँ देखो, please let me complete. So since you see, in general the condition is like this, right? B double dash should be greater than equals to should be greater than B dash, but but when you have only V equals to 0 and V equals to 1. So this number will not be close, but almost you can say this is almost close. It will not be exactly same, but that there will be not that much difference in P. So I have taken a rough example. That is, if V double dash is equals to 5 centimeter inverse, B will be around 4 centimeter inverse. Okay. So it's, you can say this is not exactly equal, but it's almost equal. That sign is that symbol is representing like this. Okay.
Yes, sir.
Okay. Now first transition will happen from where to where. So first transition will be, you have taken that selection rule, delta J equals to +1, right? And delta J is what, basically J dash minus J double dash, that is equals to +1. So first transition will happen from when J dash equals to 0 and J double dash equals to 1. So this is your J dash. I have to write like this. So 0 to 1, 0 is your J double dash to 1. 1 is basically for J dash. Now can you tell me what will be that wave number corresponding to this? New 0 bar. Now what will be this number? So very simple, right? Because J double dash is there from 0 to 1 transition. So this term will be 0 because J double dash, it contains J double dash. This is also contains J double dash. And from 0 to 1 transition, from 0 to 1 transition, J double dash is how much? 0. So obviously it will be 2B. Right? Obviously it will be 2B. Now this
2B dash होगा ना?
yes, 2B dash. Second transition will be what? 1 to 1 is your J double dash, 2 that is your J dash. So I can draw that diagram, then it will be clear. So J first line will be from J double dash equals to 0 to 1. This is your first line, because the condition what I have taken, that delta J equals to +1. So delta J means final state J minus initial J, that will be +1. So 1 minus 0 equals to +1, and second line will be 1 to 2. So that will be, that wave number will be how much now? New 0 bar plus 2B dash. Then what about this factor? Now you see what I have considered here. What I have considered, you see, if B dash is 4 centimeter inverse, B will be 5 centimeter inverse. Then how much this factor will give you? मैंने क्या?
Sir, B0 plus 6B dash minus 2B double dash.
How much? 3 into 5, 15 minus 4. It will be how much? Sorry, 3 into 4 minus 5. So it will be 7. Right?
ये वाली वैल्यूज रखी है.
कौन सा?
ये जो आपने 4 और 5 सेंटीमीटर लिए हैं.
देखो मैंने क्या अज्यूम किया था, थोड़ा बात को अच्छे से सुनो. For this level and this level, there will be not that much change in the rotational quantum number. So if B double dash, B corresponding to this level is 5 centimeter inverse. So B corresponding to this level will be around 4 centimeter inverse. Now I'll substitute this value here. So if you substitute 3 into 4, it will be 12 minus 5. So it will be 7. And J is how much here? J is how much here? 1, right? J is on here, right? Because on to 2 transitions, so J will be on. So this is all about your term. Then this term will give you what? This term is, so basically what I'm trying to say, since B dash and B double dash, there will be not that much variation. So this term will always be positive. Because B dash और B double dash के बीच में अंतर नहीं है. So obviously 3B dash minus B double dash, this will always be positive. But this term B dash minus B dash minus B double dash, that will always be negative. Okay, but I am trying to say something else. Please listen to me. So if this value will be how much? 7, right? And your J double dash is how much? On. From on to 2 transition, J dash is how much? J double dash is 1. So I'll substitute 1 here. And what about this term? So this will give you -1 simply, right? This will give you -1. So your second line, location of second line will be where? So new 0 bar plus 2b. Let us substitute b dash here also. B dash is how much? 4, right? So 8 plus 6, 14, right? Is this part clear? So I've substituted b dash here also, 2b dash. So 2 into 4, 8, and this part is 6, so 14 centimeter inverse. So your second line will be located at which place? New 0 bar plus 14 centimeter inverse. First line will be located at where? New 0 bar plus this will be how much? This is your 8. So new 0 bar plus 8 centimeter inverse. First line. Second line will be new 0 bar plus 14 centimeter inverse. What about third line? So can you tell me that gap? So initially you have only that new 0 bar you have one line. Second line will be at what? Which place? New 0 bar plus 8. So there is a gap between these two lines is basically 8. Then second line will be at which distance? 8. Then you have 6, 14. Did you get what I'm saying? What I'm saying, you have fundamental band that is at new 0 bar. Fundamental band that is at new 0 bar. Then first line corresponding to rotational level that is coming due to transition from 0 to 1. And when you are substituting this value, I have taken a rough example of b dash, that is 4. So it will be where it will be located? New 0 bar plus 2 into 4. So it will be at 8. So fundamental band is at new 0 bar. So for first rotational line will be at somewhere else, but this distance will be how much? 8 centimeter inverse. Now second line, rotational line, so that will be when on to 2 transition. And if you calculate this value by taking same data, you will get that location that is at new 0 bar plus 14 centimeter inverse. So what will be distance? So you have first new 0 bar, then first rotational line, that will be R1. That distance is how much? 8. Second, from new 0 bar to this will be 14, and this is 8. Obviously, this distance will be how much? 6 centimeter, right? So this is your R2. So you can clearly see that when you are increasing that number of transition, I mean that J value, J double dash. So first 0 to 1, 1 to 2, 2 to 3. When we will make transition from 2 to 3, that separation will be less. So your separation between line is basically becoming less when you are going to higher quantum number. So
सर
yes,
ये 8 6 R1 R2 ये कौन सा एज्यूम किया था ना?
एज्यूम किया इस तरह की वैल्यू, मतलब ये अब अगर मैं एज्यूम इस वे में किया हूँ, अगर ये 5 होगा
वैल्यू
हाँ
डिक्रीज होती जाएगी.
हाँ मैं important message is that when you are going to higher J value, that line will be closely coming. मतलब उनके बीच में सेपरेशन आपका क्या होता जाएगा? कम होता जाएगा जैसे जैसे आपका क्वांटम नंबर बढ़ाते जाओगे. So let me draw it. So first here I have drawn. Yes.
You 0 plus 18 आ रहा है 2 3 के लिए.
0 plus 18 आ रहा है. तो इसका मतलब जो आपका इस लाइन, ये जो लाइन है R2 और R3 के बीच में कितना डिस्टेंस आ जाएगा? 4 सेंटीमीटर आ जाएगा. तो डिस्टेंस कम हो रहा है, राइट? The main thing is there, I want to calculate that separation between two successive lines. So when you are increasing that J value, your separation will be less. Is this part clear?
सर इसमें जो ट्रांजिशन हो रहा है उसके बाद फोटोन निकलेंगे, मतलब 1 to 2 में जाएगा. तो मतलब हम इंटेंसिटी कैसे निकल रहा है?
Yes. You see, when it will go there, so there are two kind of absorption. Okay, so first is you have first is absorption spectra, second is emissional spectra. So when it will go to here, so you will get some black line, right? Or if you are looking for emissional spectra, so that atoms or molecules is going here, so it will come back here. So that time you will get photon, and when you will see on the screen, you will get bright spot.
ये सर मेरा क्वेश्चन है कि मतलब ये लोअर स्टेट से हायर स्टेट कैसे जा रहा है, और
हाँ
फोटोन
लोअर, हाँ तो मैंने वही तो बताया था ना आपको, जैसे आपने 310 आपने दिया था, तो कुछ आपका क्या वाइब्रेशनल के लिए काम आया था, कुछ आपका रोटेशनल के लिए आया था। तो ये आपका बेसिकली इनकमिंग फोटोन का जो एनर्जी है ना, वो आपको पंप कर रहा है। इज दिस पार्ट क्लियर?
और उसके बाद मतलब लाइट हम कैसे इसमें पा
हाँ
रहे हैं?
एग्जैक्टली, तो ये तो ज्यादा टाइम तक स्टे नहीं कर पाएगा, तो फिर ये वापसी भी आ जाएगा,
ओके,
तो वापसी भी आ
तो
जाएगा। and you don't have any single number of molecules is there, there are millions of molecule is there, so always there will be some transition will occur and you will get that light, because आपके पास एक तो मॉलिक्यूल्स नहीं है ना, आपके सब पास काफी सारे मॉलिक्यूल्स है, तो हमको पता नहीं है कि हाँ ये मॉलिक्यूल कब वापसी आएगा, बट एक मॉलिक्यूल तो नहीं है ना आपके पास, मिलियंस मॉलिक्यूल्स है ना, तो कोई ना कोई तो एक टाइम पे आपको वापसी आएगा ये।
ओके सर।
तो इसका इसका लाइन अगर ड्रॉ करोगे, व्हाट आई एम ट्राइंग टू से, इफ यू ड्रॉ द स्पेक्ट्रल लाइन, so you have nu zero bar here and you have line this side, so first line from zero, due to 0 to 1 transition, so you have some separation between these two lines, then second line because of 1 to 2 transition, but that separation between these two, so this will be your R1, you know, because for delta J plus 1 is known as R branch, so actually this is not R1 because it is happening from here to here 0 to 1, so it will be R0, it will be R0, okay. No, first line, you see, first transition is happening from 0 to 1, so it will known as R0. When it is happening from 1 to 2, that is known as R1, okay. So this separation will be smaller as compared to this. When it is making transition from 2 to 3, so that will be known as R3. Is this part clear to all what I am saying? So separation will get less, ठीक है, इतना समझ में आया? Okay, so this is so you can mention where you have written that case 1 delta J plus 1, you make a comma and write that will be your R branch. जहां पे आपने शुरू किया था टॉपिक, वहां पे डेल्टा J प्लस 1 लिखा था ना, वहां पे ये लिखो कि R ब्रांच, उसको R ब्रांच बोलते हैं, ठीक है। तो R ब्रांच को ऐसे डिनोट करते हैं R0, R1, this will be R2.
Sir,
Yes.
say it means when we are going towards right, separation is less.
Yes.
Okay, sir.
Now I'll use
सर कहाँ पे R ब्रांच लिखना है?
केस 1 जहां पे आपने मेंशन किया हो ना, केस 1 डेल्टा J प्लस 1 जहां पे लिखो शुरू में ही, वहां पे कॉमा देके लिखो R ब्रांच लिखो, ठीक है। Now you have second case, that will be case 2 delta J equals to -1, and this is known as P branch, ठीक है। So you have delta J -1 means J dash minus J double dash, that is -1. It means J dash equals to J double dash -1. So now if you substitute in your original equation, so you can mention here, okay, I have mentioned here P branch, okay. So now it will be that wave number will be how much? It will be simply nu 0 bar, okay. Then B dash, it will be J dash into J dash double dash, sorry, J double dash -1. Then last term will be B double dash J double dash plus 1, okay. So if you rewrite or arrange it, it will be new 0 bar. Then you will have b dash plus b double dash j double dash. Okay. Then next term will be b dash minus b double dash j double dash square. ठीक है, तो इसमें आप देखो एक इम्पॉर्टेंट थिंग, ये आपका न्यू 0 बार है, ये आपका माइनस, हाँ
सर वो आवाज
फिर से आवाज आ रहा है, आप ठीक है? नहीं, नो आप बताओ,
सर अभी भी है
अभी भी है? अब
सर अब बंद हो गई सर
बंद हो गई? ओके ओके ओके, नाउ दिस इज you see, this is new 0 bar, this is negative, so this is positive, right? b dash minus b double dash, this is also negative. Did you get what I'm saying? सेकेंड टर्म भी आपका क्या है, नेगेटिव कंट्रीब्यूशन है, बिकॉज आपका ऑलरेडी नेगेटिव है, बी डैश बी डबल डैश दोनों पॉजिटिव है ना, बट यू हैव नेगेटिव, सो सेकेंड टर्म इज नेगेटिव, थर्ड टर्म इज ऑल्सो नेगेटिव. तो वहां पे क्या हो रहा था कि जैसे आपका जे बढ़ा रहे थे, आप इंक्रीज कर रहे थे जे डैश, so their separation was becoming less, but since this both terms is negative here, so when you will increase that j double dash, so of course that separation will get increase here. Did you get what I'm saying? आपका सेकंड टर्म भी नेगेटिव है, थर्ड टर्म भी नेगेटिव है, तो जैसे जे डबल डैश को आप बढ़ाते जाओगे, ये नेगेटिवली बढ़ता जाएगा, मतलब आपको इस साइड आपको लाइन मिलेगा, but separation between line will get increase when you will increase that j double dash, because when you will increase that j double dash, both terms will increase and that will be negative sign. So that's why you will get that line, but that line will get, that separation between line will get increased when you have large rotational quantum number. Is this part clear or I have to explain more? Is this part clear or I have to explain more? किसी का कोई डाउट है तो बताओ, नहीं तो फिर मैं आगे जाऊँ. Okay, if not then I'll erase and I'll write. So first line will be what? Can you please tell me? So delta, please keep in mind that you have delta j equals to -1, and you know that delta j is nothing but j double dash minus j, sorry, j dash minus j double dash. This is your delta j. Okay, so first line will be what? Corresponding to on is actually the rotational quantum number of j double dash on to 0. That will be your first line, because 0 to other line is not possible, because you have to keep delta j equals to -1, and delta j is what? Basically j dash minus j double dash. j dash क्या है आपका? अपर स्टेट का क्वांटम नंबर है, j डबल डैश लोअर स्टेट का क्वांटम नंबर है, तो j डबल डैश 0 से कोई ट्रांजिशन पॉसिबल नहीं है, क्योंकि 0 के नीचे आपका कोई क्वांटम नंबर नहीं है जो आपको ये -1 दे. तो फर्स्ट जो लाइन मिलेगा आपका p ब्रांच का, वो j डबल डैश इक्वल्स टू 1 से j डैश इक्वल्स टू 0 पे फर्स्ट लाइन मिलेगा आपको. सो यू कैन मेक इट हियर आल्सो फ्रॉम 1 to 0. This will be your first line. Earlier in R branch, you can clearly see from 0 to 1 you have first line, but here from 1 to 0 you have first line. Okay, so that is known as, basically that is known as, अब यहाँ पे क्या लिखोगे? P1 लिखोगे, क्योंकि हम किस वे में डिनोट कर रहा हूँ चीज को, j डबल डैश का जो क्वांटम नंबर है उस वे में इस लाइन को डिनोट करते हैं. ठीक है, तो वहां पे 0 से 1 पे हो रहा था, R0 लिखा था, यहाँ पे क्या है, ऑन से शुरू हो रहा है, तो ऑब्वियसली दैट नंबर और नोटेशन विल बी पी ऑन. ओके, देन यू हैव 2 to 1 transition, that will be P2 line. Then 3 to 2, that will be your P3 line. तो यहाँ पे आप दिखा सकते हो, जैसे ऑन से 0 पे हुआ, फिर 2 से ऑन पे, दिस इज योर P ऑन, एंड 3 से 2 पे जब होता है इसको, ठीक है आपका.
Sir,
हाँ,
so this is all according to the selection rule, na delta J minus 1.
एग्जैक्टली. तो यहाँ पे देखो डेल्टा जे माइनस होना जाएगा, क्योंकि जे डैश 0 है, जे डैश माइनस जे डबल डैश, so 0 minus 1 1, 1 minus 2 minus 1, 2 minus 3 minus 1, right? So this side you will get line. So first line will be somewhere here.
बढ़ेगा ना लाइंस में से.
Yeah, separation will get increased now. So this will be your P on. Then separation will get increased. This will be your P2. And separation will get more. That will be P3. And you have many more lines. Now you may ask, there should be a question, right? I have written that line that is equally intense. But is this true for rotational level? Is this true for rotational level? So this
No, sir.
no. So first line was your vibrational, that is fundamental line, and this is corresponds to rotational line. And of course, there will not be a rotational, that intensity will not be constant. I'll write that actual notation, that spectrum, but you know these things. I'll write that that time it will be clear. But if you write that rotational, P branch and R branch in combined way, so there will be one complete formula that will be nu bar equals to nu 0 bar plus b dash m plus b dash here, b double dash here, b dash minus b double dash m square. ठीक है, जब आपका m इक्वल्स टू माइनस जे डैश है ना, और जे डैश का वैल्यू क्या क्या हो सकता है, ऑन, माइनस 2, -3. So that will give you P on, P2, P3, these lines. मतलब m के जगह पे अगर j डबल डैश माइनस जे डबल डैश सब्स्टिट्यूट करोगे, तो आपका जो P ब्रांच का इक्वेशन है वो आ जाएगा इसमें से. ये आपका जनरल फॉर्म है, दोनों जो ब्रांच है उनका कॉम्बाइंड फॉर्म है. तो यहाँ पे m के जगह पे अगर माइनस जे डबल डैश बैठा दोगे, तो you will get that expression what you have derived for P branch. And of course you know that J double dash started from on, right, for P branch. So it will be -1, -2, -3, that will represent P on, P2, P3 line and so on. And if you substitute, so this corresponds to, you can say this corresponds to P branch. But when we substitute m equals to J double dash plus 1, and for R branch, you know, J double dash will start from 0, right? So 0 plus 1, that will give you 1, 1 plus 1, that will give you 2, 2 plus 1, that will give you 3, and so on. So and that will represent basically R0, R1, R2 lines.
सर आई थिंक J -1 होगा सर.
कौन सा?
सर J -1 होना चाहिए फिर तो सर. ठीक है सर, 0 to 1 करते हैं ना सर.
0 to 1.
हाँ सर, तो फिर 0 होगा ना सर, J डैश की जगह, फिर वो 1 हो जाएगा, तो R1 होना चाहिए. आई थिंक J डैश -1 होना चाहिए.
ये वाला?
यस सर.
नहीं, ये करेक्ट है. इसको अगर इसमें सब्स्टिट्यूट कर,
ओके हाँ ओके सर, ओके.
हाँ, ये correct है.
ठीक है सर, ठीक.
अगर आपका m का वैल्यू 0 है, तो ये आपका कौन सा ब्रांच आ गया? पहले आपका P ब्रांच आ गया, ये आपका R ब्रांच है, ठीक है। और आपका जो लास्ट अगर m का वैल्यू 0 सब्स्टिट्यूट करोगे तो फिर वो क्या देगा आपका, दैट विल गिव यू फंडामेंटल बैंड,
यस सर।
बिकॉज जब m का वैल्यू 0 सब्स्टिट्यूट कर दोगे ये आपको मिलेगा, और ये क्या बेसिकली ये है, दिस रिप्रेजेंट फंडामेंटल बैंड. Now you see, this is the general form of two branches, right? So we can derive both branches from here itself by choosing the value of m, right? Now I am interested to draw the curve between nu dash and m. Okay, so shall I erase this part?
सर
Yes. हाँ, yes.
तो ट्रांजिशन होगा वही हमारा फंडामेंटल बैंड है ना?
हाँ, वाइब्रेशन लेवल के बीच में जो ट्रांजिशन होगा वो आपका फंडामेंटल बैंड, मतलब v इक्वल्स टू 0 से v इक्वल्स टू 1 पे जो ट्रांजिशन है वो फंडामेंटल बैंड है, वो मोस्ट डोमिनेंट है, बट उसके साथ आपको ये सारे लाइन मिलेगा, इट विल बी मोस्ट इंटेंस, दिस विल बी मोस्ट इंटेंस, दिस corresponds to vibrational transition, and these are the additional candidate, rotational. Okay, is this part clear?
यस सर।
Okay, now I am interested to draw that spectrum, or you can say curve between nu and m. So if you draw it, so along this axis I will take wave number nu dash semi inverse, okay, and this axis I will take m. So m can be 0, 1, 2, so on. So how this if you draw, how this expression is look like, so how it will be if you draw m versus nu versus m, so it will look like a kind of parabola.
Yes, sir.
Okay, and m can take which value, n can take, you see what value m can take. When you will take m equals to 0, that will basically, when m equals to 0, that is basically your fundamental band, right? All values are not allowed. I have drawn this line, but these all values are not allowed. That values that will be allowed, that I will take, or that I will denote. So first, when m equals to 0, that will be your fundamental band. Now if you take m equals to -1, so m equals to -1 means this, right? P branch, m equals to -1, okay, that corresponds to P1. So where it will be located, where it will be located,
Lower.
so m equals to -1 here, okay, and of course that location, that frequency will be less as compared to nu 0 bar, so it will be somewhere here, because आपका जो टर्म आया था वो क्या था, nu 0 bar minus something, and of course you have drawn that P1 left to your nu 0, right? यहाँ पे आपका nu 0 था, इधर आपका P1 था लेफ्ट में ना, तो यहाँ पे लाई करेगा. सिमिलरली m इक्वल्स टू -2 के लिए यहाँ पे होगा. ऑफकोर्स दिस सेपरेशन, ये जो सेपरेशन है इससे लार्ज होना चाहिए, तो आपका P1 है आपका, और आपका P2 है, और इधर आपको क्या मिलेगा, m इक्वल्स टू 1 के करस्पॉन्डिंग आपको क्या मिलेगा, R0 मिलेगा, राइट? m इक्वल्स टू 2 के करस्पॉन्डिंग क्या मिलेगा आपको, R1 मिलेगा, तो इस साइड आपका R0 R1 होते होते ये यहाँ पे जो है आपका R ब्रांच का मैक्सिमम फ्रीक्वेंसी मिलेगा, इस जगह पे R0 का मैक्सिमम फ्रीक्वेंसी मिलेगा. फिर उसके ऊपर जाओगे तो फ्रीक्वेंसी देखो कम होता जा रहा है, उसके ऊपर अगर आप m बढ़ाते जा रहे हो फ्रीक्वेंसी कम होता जा रहा है. डिड यू नोटिस, ये आपका m बढ़ाते जा रहे हो, योर फ्रीक्वेंसी इज गेटिंग हाई, और वेव नंबर यू कैन से इट इज गेटिंग हाई, राइट? बट एट सम पॉइंट if you increase m more, your frequency is getting less. You see, it is coming back. the frequency is getting less. So you will get some line here. Theoretically, experimentally, it is not possible. You will get some spot, and that will have less frequency as compared to this. This is basically vortex. Or you can say band head. तो ये क्यों आ रहा है? जैसे आप m बढ़ाते जा रहे हो तो वहां पे देखो फ्रीक्वेंसी कम होता जा रहा है बैंड हेड के बाद. Why is it is coming actually?
सेपरेशन तो कम हो रहा है.
कम हो रहा है क्योंकि देखो जो आपका लास्ट टर्म था, लास्ट टर्म एक्चुअली नेगेटिव इन साइन. लास्ट टर्म इज नेगेटिवली इन साइन and negatively in sign with z that content j double dash, right? And j double dash actually depends upon m. So m basically j double dash के ऊपर डिपेंड कर रहा है. अब j double dash जब जैसे जैसे बढ़ रहा है वो नेगेटिव कंट्रीब्यूशन का बढ़ रहा है, इंक्रीज हो रहा है, बट एक टाइम आ जाएगा जब उसका कंट्रीब्यूशन बढ़ता जाएगा और वो क्या करेगा, नेगेटिव कंट्रीब्यूशन देगा, है ना. तो जे थर्ड टर्म के कारण जो है वो जो आपका बैक आ रहा है ना, न्यू का जो सॉरी न्यू बार का जो लेस होने का कारण जो थर्ड टर्म है, क्योंकि जब आप जे डबल डैश इक्वल्स टू 100 के ऊपर चले जाओगे, सो देन व्हाट विल हैपन, योर वेव नंबर विल गेट लेस. सो practically theoretically you will get this spot, but experimentally it is not possible. Why? So I said theoretically you will get this branch point, but experimentally it is not possible.
बढ़ाना पॉसिबल नहीं है.
Exactly, because you see, when I am dealing with this j, I am saying when j will be very large, that time you will get that spot, and j around 100. Experimentally की क्या उस उतना लेवल में मॉलिक्यूल को एक्साइट करना पॉसिबल है? ज्यादातर मॉलिक्यूल कहाँ पे लाई करते हैं? ग्राउंड पे लाई करते हैं, राइट? So that's why theoretically you will get that spot, but experimentally it is not possible.
1 2 को तो हम हॉट बैंड है,
Sorry,
तो उसके ऊपर तो और भी टेम्परेचर है.
sorry.
1 to 2 बैंड को ही तो हम हॉट बैंड कहते हैं.
Exactly, exactly. Thank you. Yes, yes, very, very good. 1 से 2 को हम हॉट बैंड बोलते हैं, तो वहां तो पॉसिबल ही नहीं है. तो that's why theoretically we may get, but experimentally not possible. But Southern, can you please tell me that, can you please calculate this wave number corresponding to band head? So this is basically denoted by new head. How will calculate this new head?
Maximum minimum condition.
Exactly. So
Derivative.
exactly. So I have to differentiate it, right? Then
Yes.
I can calculate. So shall I erase this part?
Yes.
So to calculate new head, you have to differentiate d nu bar by dm equals to 0, and you have to calculate m, right? M you have to calculate, then you have to substitute. I'll not do that, but I'll do problem on that. So if you have completed, then let us solve few problems. Another thing, as I mentioned, I should draw this actual spectrum. So let me draw it. तो आपका यहाँ पे एक फंडामेंटल बैंड आ जाएगा जो काफी इंटेंस है, राइट? ठीक है, आपका न्यू जीरो बार है. और जो रोटेशनल का स्पेक्ट्रम किस तरह से होता है? तो यहाँ पे आपका लाइन रहेगा. Is this clear to all? So now you can mention this is your R0, R1, R2, and so on. This side you have P1, P2, P3, and so on. Okay. Okay. Can we do now problem?
Yes.
So first problem. We have rotational vibrational energy, that is EJV, that is given. EJV is given h cross omega by 2, h cross omega v plus h cross omega v plus half. Okay, and b j into j plus 1. This is your vibrational rotational energy is given, h cross omega v plus half b j into j plus 1. So you can clearly see that anharmonic term is neglected here. Okay, now what they have said, that consider the transition. You can see that consider the transition in which both the initial and final state, consider the transition in which both the initial and final states are restricted to v greater than less than equals to 1 and j less than equals to 3. So consider the transition in which both the initial and final state are restricted to v less than equals to 1, j less than equals to 3, and also they have mentioned that selection rule for this transition is delta j equals to plus minus 1 and delta v equals to plus minus 1. Then they ask what will be the largest allowed energy for this transition. So you have rotational vibrational energy is this much, and transition is restricted to only this level, v less than equals to 1, j less than equals to 3. Selection rule they have provided delta j plus minus 1, delta v plus minus 1. And the question is how much will be the largest energy for allowed transition. How much will be the largest energy for allowed transition? So transition किस में restricted है? V less than equals to 1 पे, right? And J less than equals to 3 पे. तो V less than equals to 1 मतलब किस में possible है? V 0 to 1 and इसमें क्या है आपका J कितना लेवल ले सकते हो आप J का 0 2 3, right? Okay, let me take. So you have V equals to 0 here, V equals to 0 here, and V equals to 1. Only this is allowed. V equals to 1, and that rotational level you can take J0 on 2 3. Here also you can take 0 on 2 3. So this is your J, right? J0 on 2 3. Okay, here also 0 on 2 3. तो वाइब्रेशनल के लिए तो कितना है, ये है आपका वाइब्रेशनल के लिए, है ना, यही पॉसिबल है, दैट विल बी h क्रॉस ओमेगा. रोटेशनल का मैक्सिमम कब पॉसिबल है? रोटेशनल का मैक्सिमम एनर्जी कब पॉसिबल? डेल्टा जे प्लस माइनस 1. तो 0 से 1 में जाएगा तो फिर कितना आएगा आपका? 0 से 1 में 2b आएगा, राइट?
yes,
यहाँ से कितना जाएगा? 1 से 2 में अगर आपको मैक्सिमम अलाउड एनर्जी देखना पड़ेगा, तो ये तो आपका फिक्स्ड है, v के लिए आपका कितना है? h क्रॉस ओमेगा है. अगर 0 से 1 में लेके जाओगे सिलेक्शन रूल को यूज करके, तो यहाँ पे एनर्जी कितना है इसका कॉरस्पॉन्डिंग? 2b है. इसका कॉरस्पॉन्डिंग 1 से 2 again delta J, on set 2, that will be again delta J plus 1, that will provide you 4B. Then 2 to 3, that will provide you 6B. And you are restricted up to this. You cannot make beyond this, right? Because this is the condition they have provided, right? So largest इनमें से कौन सा है? 2 to 3 में जब हो रहा है ना, तो largest amount of energy कितना हो गया ट्रांजिशन का? So yes.
So 6B, you are putting J equals to, then only 6B is coming.
Sorry.
So how you are knowing the energy of this rotational one?
This is the rotational energy, right?
Yes, sir. So when the transition is between 3,
2 to 3. Yeah.
yes, sir.
Because they have provided the selection rule, right? Delta
Yes,
J
sir,
plus
no. This I am understanding. How you are calculating the energy?
Yes, so you can calculate. So corresponding to this transition 2 to 3, how will calculate? So that energy will be how much? So it will be energy of 3 level, rotational 3 level minus energy of 2 level. So Bj into J plus 1. So B here, how much I have to substitute? 3. So 3 into 2, 4, right? Minus, then B
6. Okay, sir, understand.
It will be 60.
Yes, sir. Thank you, sir.
So the largest amount of energy will be how much? H cross omega plus 60. Okay. So you have to look this value, how much restriction they have given. Okay. So you have to choose in this way. So it is clear when you will increase that J. So at largest J, you will have large amount of energy. Okay. Always keep in mind. So जब आपको 3 दिया है, इसका मतलब 2 से 3 आपका maximum rotational energy possible है. ठीक है. And this is only there are 2 levels are possible, so obviously this number will come. This is
होगा.
हाँ,
एक HC मल्टीप्लाई नहीं होगा वो एनर्जी में 6B HC से.
हाँ, एक्चुअली क्या है ना, उन लोगों ने दिया नहीं, इसी यूनिट में दिया है, ये आपका एनर्जी फॉर्म में दिया है. एक्चुअली दे में फॉरवर्ड, बट जिस वे में आपको एनर्जी का एक्सप्रेशन ना ये गिवन है. ओके, बट या टेक्निकली इफ यू सी साइंटिफिकली, ऑफ कोर्स देयर विल बी सी, राइट? नॉट ओनली सी, HC विल बी देयर. Yeah, but what they have provided you, that is the energy. They mentioned this is the energy of rotational vibrational spectroscopy. So I have to deal what they have given like that also. But absolutely you are correct, because this is all about wave number. So you have to multiply this factor with HC. But according to question, this is the answer. Okay, Sultan? Okay. Next question. So wave number corresponding to fundamental band they have given. Wave number corresponding to the fundamental band of CN molecule. Molecule is CN. Wave number is given nu dash in centimeter inverse, that is 25798. 25798 plus 3.85 m plus 0.068 m square. So this is the wave number corresponding to fundamental transition they have provided. And they asked, what is the location of band head? Location of band head. Yes.
3.85 m plus 0. क्या है मतलब?
0.068 m square. 0.068 m square. 2.25798 plus 3.85 m plus 0.068 m square, and that is given in centimeter meters. So you have to calculate the location of band head. So very interesting thing. So we know that general expression of our wave number, right? That is what? Nu 0 bar plus what is that? B dash plus B double dash m, and you have last term, that is B dash minus B double dash m square. So these things they have provided. Nu 0 bar, that is this. B dash plus B double dash, that is 3.85, and B dash minus B double dash, that is 0.068. So I'll use this general expression. So how will calculate that band height? So del nu dash by del m bar actually, and that will be 0. I have to set because this is the value of m at which nu is maximum. So if you calculate it, first term will give 0, and second term will provide you B dash plus B double dash, and of course last term will give you 2, right? 2 B dash minus B double dash m, right? So it means m is how much? Minus B dash B double dash divided by twice B dash minus B double dash. So you got m, you substitute it here, then you will get that location of band height, right? Is this part clear to all? I'm using general expression. You can use this part also, no problem. So this I'll substitute these things here, then I'll get that expression in terms of nu 0 bar, B plus B double dash, and B minus B double dash, and I know everything, every values. This value is nu 0 bar, this is B plus B dash plus B double dash, and this is B dash minus B double dash. Now can you please substitute the same here?
Yes sir.
Please submit.
28 आ रहा है सर, approximate
कितना आ रहा है?
So minus 28.30.
Okay, let me.
हाँ पॉइंट करिए, लेकिन 28 होगा ना सर, हम मतलब कि इंटीजर है ना?
हाँ yes. Let me solve.
28.30.
कितना आ रहा है? अच्छा m को आप कैलकुलेट कर रहे हो?
Minus
Yes, sir.
28.30.
Okay, m you are calculating. Yes, you can do. But what I'm saying, you can do also, no problem. What I'm saying, you will just substitute it here. So you can do that part also. So location of band head will be, if you substitute this expression here, then how much you'll get? So nu 0 bar, then second term will provide you B dash plus B double dash whole square, right? B dash B double dash whole square divided by twice B dash minus B double dash, right? And third term will give you, please check it, third term will give you B dash plus B double dash whole square divided by 4 B dash minus B double dash. Okay, so if you combine it, you will basically get nu 0 bar minus B dash plus B double dash whole square divided by 4 B dash minus B double dash. Now you know where that value is, right? So I'll substitute this. So the location of band head will be, so these values was nu 0 was 25798. Then these values were how much? This was 3.85 square divided by 4 into 0.068. Is this part clear? Okay.
Yes sir.
सबका आया कितना आ रहा है?
सर 25 6 सर ये 3/4 होगा, दोनों माइनस है ना?
कौन सा 3 बाई
अच्छा,
4?
ठीक है सर, ठीक है ठीक है ठीक है सर, ठीक है वो मैंने गलती की, ठीक है।
हाँ देख लो कितना आ रहा है।
सर 25,743.5।
Good. So you can write 25,744 centimeter in bar. Okay. So I think time is over. Tomorrow I'll do one or two problem. Then we'll go to that Raman spectra. Okay. This is the important part for your exam. Okay.
सर इसमें m का वैल्यू नेगेटिव क्यों आ रहा है?
M का वैल्यू नेगेटिव क्यों आ रहा है?
मतलब बैंड हेड तो पॉजिटिव साइड में था, m का पॉजिटिव साइड में था।
हाँ M का वैल्यू नेगेटिव नहीं है। देखो ये आपका क्या है, b डैश माइनस b डबल डैश, राइट? ये आपका नेगेटिव नहीं है।
सर नेगेटिव ही आ रहा है m का वैल्यू।
इसका वैल्यू नेगेटिव आ रहा है, m का वैल्यू
मतलब -28
m का वैल्यू की क्या एक्सप्रेशन था m का? माइनस b बार
माइनस b डैश प्लस b डबल डैश
हाँ
अपॉन 2 into b डैश माइनस b डबल डैश।
okay okay according to that given condition we are getting, yes, m should not be negative here, but what they have provided that data according to this is coming like this. Okay, so this is the way to calculate that band aid, right? It should be positive, but what they have provided that data now, you have to proceed like this. There is no other option, you know. You are absolutely correct. M should be positive. M should be positive, but whatever they have provided the data according to this is the answer. Okay, so tomorrow I'll do one or two problem, then we'll go to the Raman part. Okay.
Okay,
Okay, I should stop here.
thank you sir.
थैंक यू।
Welcome.
थैंक यू सर।
Welcome.
Thank you, sir.